Hello. In this lesson we will be covering the 6 trigonometric functions, which are the sine, cosine, tangent, secant, cosecant, and cotangent functions. To start off, let us consider a circle in the xy plane with radius 1. We call this the unit circle due to this property of it having radius 1. If you imagine drawing a line at some angle to the horizontal, let's call this angle theta. This line will cross the circle at a point, only one point. Let's call this point A. Notice that every point on the circle can be uniquely associated with some angle of the horizontal. This line is also a radius of the circle, meaning it always has a length of 1. As it turns out, it is very useful to know the xy coordinates of a point on the circle in relation and not to the coordinates, not to either the x or y, but to this angle property that each point is associated with. This is where the sine and cosine functions come in. In addition to our line to a point on the circle, let's draw another line as so that we have a right-angled triangle. You may start to see where this is going if you have prior knowledge about trigonometric functions, and if you do, you may also know that for a right-angled triangle, the sine of an angle in that triangle is the opposite side of to the angle divided by the hypotenuse. That's all well and good, but what does this actually mean? If we think in the context of our unit circle, this seemingly arbitrary operation starts making more sense. Take a look at this division. One way to think about what you're doing here is that you're asking, if these two quantities remained in this proportion, but the hypotenuse had a length of 1, how long would the opposite be? Well, it would be angle to the sine of our angle theta. Or in other words, if the length of the hypotenuse is 1, then the opposite must be equal to the sine of the angle. But look at what this is telling us. It's telling us that the opposite, which is the height of A above the horizontal, we found that it's equal to the sine of this angle. And the height of A above the horizontal is defined as its y-coordinate. So that's what the sine function is really telling us. It's telling us the y-coordinate of this point A. Now the cosine function is very similar to the sine. Unlike the sine, the cosine of an angle in a right triangle is the adjacent divided by the hypotenuse, meaning that if the hypotenuse has length 1, the adjacent is the cosine of the angle, meaning that on our unit circle, the cosine is this, the adjacent side, which is just the x-coordinate of the point. Another thing to notice is that the angles are not limited to just going between 0 and 90 degrees. They can go all the way around this circle. So that means we can draw a line at any point, at any angle to the horizontal, not just between here and here. That means that the sine and cosine are defined for all angles from 0 to 360 and even beyond if you imagine rotating this line, going back to the horizontal, and then continuing to rotate around the circle. So formally we think of the sine and cosine functions as functions of theta, which is an angle of the horizontal, and what they tell us are the x and y coordinates of the point where that line intersects the unit circle. The sine and cosine are the two basic trigonometric functions from which the rest are built, meaning that all other trigonometric functions can be expressed in terms of sine and cosine. The tangent is the most commonly used one of these, and it is equal to the sine over the cosine. If you think about this in terms of our triangle, this should make sense, as the tangent is the ratio of the opposite to the adjacent. And if we look back at the triangle in our circle, the opposite is equal to the sine, the adjacent is equal to the cosine, meaning that the ratio of sine to cosine is the same as the ratio of the opposite to the adjacent. The other ratios are used less frequently than the tangent, but you still need to know them for the IGCSE additional math course. They are the reciprocals of the first three functions. The cosecant is the reciprocal of sine. It is 1 over sine theta. And if you think about the original opposite over hypotenuse, the reciprocal of that would flip the fraction, making it hypotenuse over opposite. The secant is the same for the cosine, making it 1 over cosine, and the hypotenuse over the adjacent. And the cotangent is 1 over tan theta. So you flip the fraction and it becomes adjacent over opposite instead of opposite over adjacent.